So we have today's class about exponential distribution. A random variable, a continuous random variable defined in 0, infinity is said to follow the exponential distribution if the probability density function f of x is equal to lambda into e to the power minus lambda x and the x value greater than or equal to 0. Applications. The exponential distribution is used in green theory and reliability theory. Time to failure of a component and the time between arrivals can be modeled using exponential distribution. Next is the moment generating function. For moment generating function is the continuous random variable. The continuous random variable moment generating function formula for mx of t is equal to minus 52 plus 50 e power tx into f of x into dx. That is 0 to infinity e power tx into why it is 0 to infinity because of the formula. PDF of the exponential distribution is here lambda into x e to the power minus lambda x greater than or equal to 0. So now x greater than or equal to 0. So instead of the formula minus 52 plus 50 is 0 to infinity e power tx into instead of f of x is equal to lambda into e to the power minus lambda x into dx. So here lambda is the common constant 0 to infinity e power tx into e power minus lambda x into dx. So instead of this exponential powers, take one minus of x is the common. So lambda into t, lambda minus t into x into dx. As per the integration of e power minus ax into dx is equal to e power minus ax by minus a. So here the coefficient of x is equal to minus of lambda minus t. So it has to be in the denominator coefficient of x. So lambda is the constant e power minus of lambda minus t into x divided by minus of lambda minus t. Now close the limit from 0 to infinity. Now lambda is the constant. Upper limit of x is equal to infinity minus lower limit of x is equal to 0. So e to the power minus is equal to 0 minus of e power here 0 is equal to 1. So minus into minus plus 1 by lambda minus t is the answer. Already lambda is the constant outside. So lambda by lambda minus t. Next is the moment generating function. After the moment generating function, mean and a variance. Now the formula for E of x mean is equals to, this is the d by dt into mx of t and t equal to 0. We have moment generating function is lambda by lambda minus t. So d by dt of lambda by lambda minus t and put a differentiate with respect to t and t equal to 0. Here lambda is the constant because of the differentiation function is t. So now and we have to differentiate here 1 by lambda minus t. If you bring it to the numerator, it is lambda minus t whole power minus 1. Now this is the formula as per the formula for x minus a whole power n is equal to n into x minus a whole power n minus 1. So now here minus 1 into the differentiation is lambda minus t whole power minus 1, so it is minus 2. Now coefficient differentiation of minus t is equals to differentiation of minus t equal to minus 1 and put t equal to 0. So minus into minus plus, here lambda is there. So now put t equal to 0. This is 0. So lambda power minus 2. If we bring it to the denominator, this is lambda square. So lambda by lambda square equal to 1 by lambda. Now e of x square. So now e of x square differentiate with respect to t again and t equal to 0. So now after the differentiation, this is the value minus into minus plus lambda by lambda minus t whole square. This is the first derivative value. Now this we have to differentiate again. Now lambda is the constant differentiation of this minus 2 into lambda minus 2 whole power minus 2 minus 1. So minus 2 minus 1 equal to minus 3. Now again differentiate minus t with respect to t, it is minus 1 and put t equal to 0. Now put t equal to 0, this is 0. So lambda power minus 3 minus into minus plus 2 divided by lambda minus 3 whole power 3. Already in the numerator we have one lambda is there. So lambda by put t equal to 0, this is lambda power 3 only. So 2 lambda by lambda power 3, after lambda get cancelled to 2 by lambda square. This is the value of e square, e of x square. Now variance of x, e of x square minus e of x the whole square. E of x square is 2 by lambda square minus E of x whole square. E of x is equal to 1 by lambda. So 1 by lambda whole square is minus 1 by lambda square. So 2 minus 1 equal to 1 by lambda square. Next problems for the exponential distribution. So before we start the problem, we have one property. Remember in this property statement, if x is exponential distributed with the parameter lambda, then for any two positive integer s and t, p of x greater than s plus t bar x greater than s. So we can say it is a conditional probability, so it is given p of x greater than s plus t given x greater than s, which is equal to p of x greater than t. Now the proof, p of x greater than s plus t given x greater than s, numerator, this is the LHS part, which is equals to, so now as per the conditional probability, p of a given b, p of a given b is equal to p of a intersection b bar p of b. So now this is, consider this is a and this is b. So P of A bar B is equals to P of A intersection B x greater than s plus t intersection B divided by P of B. B is equal to x greater than s. So P of B, which is equals to, now x greater than s plus t intersection x greater than s. So the intersection between x greater than s plus t and x greater than s is equal to x greater than s plus t. So now intersection of these two is equal to p of x greater than s plus t divided by p of x greater than s. Now we have to find x greater than s plus t and the p of x greater than s. X greater than k is equals to, in general, this is for the continuous random variable. So for the continuous random variable, x greater than k means integration from k to infinity f of x into dx. We have f of x is equal to lambda into e to the power minus lambda x into dx. So now k to infinity f of x value lambda into e to the power minus lambda x into dx. Take lambda value outside. E power minus lambda x into dx, e power minus lambda x divided by minus lambda. Close the limit from k to infinity, so k to infinity. Now lambda gets cancelled, here minus is there, so minus of, as x is equal to infinity e power minus infinity minus x is equal to k is e power minus lambda k. So minus into minus is plus. So e power minus lambda k. This is the value for x greater than k. So in this way, find out the numerator and the denominator. So x greater than s plus t, instead of k is equals to x plus s plus t, which is equal to e to the power minus of lambda into, instead of k, x greater than k means e power minus k. X greater than s plus t, instead of k is equals to here s plus t. So the answer e power minus into, instead of k is equal to s plus t. And also p of x greater than s. Now x greater than k is e power minus lambda k. E power p of x greater than s is e power minus lambda s. Now the overall formula, this is the property p of x greater than s plus t given x greater than s, which is equal to, the value of p of x greater than s plus t is equal to e power minus lambda into s plus t divided by p of x greater than s. X greater than s is equal to e power minus lambda s. Now in the numerator is e power minus lambda s into e power minus lambda t divided by e power minus lambda s. On e power minus lambda s, a lambda s cancelled, so e power minus lambda into t, which is nothing but p of x greater than t. Hence, the memoryless property is satisfied. Therefore, p of x greater than s plus t given x greater than s is equal to p of x greater than t. So, this is what our right hand side. Hence, we prove the property. Now, the first question based upon the above property. The time in hours required to repair a machine is exponentially distributed with the parameter lambda. What is the probability that the repair time exceeds 2 hours? What is the conditional probability that a repair takes at least 10 hour given time? Its duration exceeds 9th hour. So we have the first formula, continuous distribution of the exponential distribution. PDF is equal to f of x is equal to lambda into e power minus lambda x greater than 0. Now f of x is equal to, here the values of parameter given lambda is equal to 1 by 2. So 1 by 2 into e power minus 1 by 2 into x, so e power minus x by 2 and x greater than 0. Now the first question, what is the probability that a repair time takes at least, here exceeds 2. So at least 2, 2 and more than 2, exceeds 2 only x greater than 2. So 2 to infinity f of x into dx. So 2 to infinity into, this is the value of f of x, so 1 by 2 into e power minus x by 2 into dx. So 1 by 2 into the integration of this e power minus x by 2 by coefficient of x minus 1 by 2. So minus 1 by 2. So now 1 by 2, 1 by 2 cancelled. It is minus 1 is there. Now as upper limit x is equal to infinity, e power minus infinity, minus lower limit x is equal to 2, e power minus lower limit of x is equal to 2, e power minus 2 by 2 equal to minus 1. Now 0, e power minus infinity equal to 0, 0 minus e power minus 1. So minus get cancelled, it is e power minus 1. The calculation for e power minus 1 equal to 0.3679. So this is the calculation of probability of at least exceeds 2 hours for the first submission. Now the second question, what is the conditional probability that a repair takes at least 10 hours given that its duration exceeds 9th hour? So we have to use the conditional probability as per the above property. If the exponential distribution with the parameter lambda for any two positive integers s and t, then p of x greater than s plus t given x greater than s is equal to p of x greater than t. Now in the same we are going to using the property. Now the question is, what is the conditional probability? So this is the conditional probability. A repair takes at least 10 hours. So at least 10 hours is p of x greater than or equal to 10. Conditional probability given. Its duration exceeds 9th hour. So given x greater than 9. So now as per the property, x greater than s plus t bar x greater than s is equal to x greater than t. So x greater than t. Now this 10 for our problem statement, for our satisfaction we can write 10 is equal to p of 9 plus 1. P of 9 plus 1 equal to p of 1. So x greater than 1, this is the above property. So this we can write p of x greater than 1. So x greater than 1 is equal to 1 to infinity f of x into dx, where f of x is equal to 1 by 2 into e power minus x by 2 into dx. Now 1 by 2 take it outside. Now integration of e power minus ax into dx is equal to e power minus ax by minus a. So 1 by 2 into e power minus x by 2 by minus 1 by 2. Close the limit from 1 to infinity. Now 1 by 2 get cancelled to minus of, as x is equal to 0, e power minus x is equal to infinity, e power minus infinity, minus lower limit x is equal to 1, e power minus 1 by 2. So now minus of e power minus infinity equal to 0. So now minus into minus plus e power minus 1 by 2. E power minus 1 by 2 answer is 0.6065. This is the final answer. Now in the next question, the mileage which car owners get with a certain kind of radial tire is a random variable having an exponential distribution with a mean is equal to 40,000 kilometers. Find the probability that one of these tires will last at least 20 kilometers, at most 30 kilometers. Now the mean, we have the formula for mean. Mean is equal to, it is given with the 1 by lambda. So here mean. We have the formula for the exponential distribution mean. So the mean of the exponential distribution here, e of x is equal to 1 by lambda, and also variance is equal to 1 by lambda square. So in this question, The values are given with the mean. So mean is equal to, as per the formula, 1 by lambda. 1 by lambda equal to 40,000, hence lambda is equal to 1 by 40,000. So now f of x is equal to lambda into e to the power minus lambda x. So x greater than 0. This is the formula. Now f of x is equal to, here lambda is equal to 1 by 40,000 into e power minus x by 40,000. Here x greater than 0. So now the first question, at least 20,000 kilometers. So x greater than or equal to 20,000, which is equal to 20,000 to infinity f of x into dx. So 20,000 to infinity f of x is equal to lambda into e to the power minus lambda x. So 1 by 40,000 into e power minus x by 40,000 into dx. So 1 by 40,000 into the integration of this e power minus ax integration is e power minus ax by minus ax. So e power minus x by 40,000 into divided by 1 by coefficient of x 1 by 40,000. So after 1 by 40,000, 1 by 40,000, first upper limit, after we cancelled it is minus of, as x is equal to infinity e power minus infinity minus lower limit x is equal to 20,000. So 20,000 by 40,000 equal to 1 by 2. So minus 1 by 2. So now e power minus infinity is 0 minus, so minus into minus a plus, so plus e power minus 1 by 2. The calculation for e power minus 1 by 2 equal to 0.6065. Now the second subdivision is at most 30 kilometers. So P of x greater than or equal to 30,000 kilometers. Because of the at most 30, it is below and 30 and below 30. So x less than or equal to 30 kilometers. So after integration 0 to 30,000 into f of x into dx, we have the x. Here f of x is equals to lambda into e power minus lambda x, where lambda is equal to, here 1 by 40,000. So 1 by 40,000 into e power lambda value e power minus x by 40,000 into dx. Now 1 by 40,000 into the integration of e power minus x by 40,000, which is equal to in e power minus ax by minus a. So e power minus of x by 40,000 by coefficient of x is equal to minus 1 by 40,000. Now 1 by 40,000, 40,000 get cancelled. X is equal to 30,000. So e power minus 3 by 4 minus lower limit of x is equal to 0. So e power 0 equal to 1. So now after we multiply by minus inside, so 1 minus e power minus 30,000 by 40,000 is equal to 1 minus e to the power minus 3 by 4. So the calculation of this is 0.527. Now in the next question, the length of time a person speaks over phone follows exponential distribution with the means equal to 6. What is the probability that a person will talk for more than 8 minutes, less than 4 minutes, and between 4 and 8 minutes? Now it is given with the mean is equal to 6. So mean of the exponential distribution 1 by lambda. So 1 by lambda equal to 6, lambda equal to 1 by 6. And the PDF of exponential distribution f of x is equals to lambda into e power minus lambda x, where x greater than or equal to 0. So here lambda is equal to 1 by 6. So 1 by 6 into e to the power minus x by 6, where x greater than 0. The first one is more than 8 minutes, so x greater than t, 8. So 8 to infinity f of x into dx. Now the value of f of x here 1 by 6 into e to the power minus x by 6. After 1 by 1 by 6 get cancelled, the minus of, as x is equal to infinity minus lower limit of x is equal to 8. So 0 minus e power minus 8 by 6. Minus 8 by 6 is equal to minus 4 by 3. Already we have the common minus is there. So minus into minus plus e power minus 4 by 3. The calculation of e power minus 4 by 3 is 0.2635. Now in the second question is less than 4 minutes. So less than 4 minutes p of x less than 4. So 0 to 4 f of x into dx. Now 0 to 4 into the value of f of x is equal to lambda into e to the power minus lambda x. Here the f of x value, after we substituting here, this is the f of x value into dx. So now 1 by 6 constant e power minus x by 6 divided by minus 1 by 6. After cancellation of this 1 by 6, 1 by 6 minus of upper limit of x is equal to 4, e power minus 4 by 6 minus lower limit of x is equal to 0, e power 0 equal to 1. So multiply by minus inside 1 minus e power minus 2 by 3. The calculation of 1 minus e to the power minus 2 by 3 is 0.4865. And the third subdivision P of between 4 and 8 minutes. So 4 less than x less than 8. In continuous random variable, we can write either 4 less than x less than 8 or 4 less than or equal to x less than or equal to 8. So 4 to 8, 1 by 6 into e power minus x by 6 into dx. So 1 by 6 into the integration e power minus x by 6 by minus 1 by 6. After 1 by 6, 1 by 6 cancellation, let us minus of e power minus x is equal to 8. So minus 8 by 6 is minus 4 by 3. Minus of lower limit x is equal to 4. Minus 4 by 6 is minus 2 by 3. Here minus is, we have minus outside. So multiply by minus inside. So e power minus 2 by 3 minus 4 by 3. So the value of e power minus 2 by 3 is equal to 0.5134. Minus of e power minus 4 by 3 is, here the answer after the subtraction 0.2499. And the rest of the question for the practice. Thanks all. Thank you all.